So we've moved into part 3 now, where we build the LFS Cross Toolchain and some temporary tools before we go on to chapter 8, where we build the final system. So everything we build in this part, in chapters 5, 6 and 7, are temporary, for temporary use for building chapter 8, and then everything in chapter 8 is what comprises the final Linux from scratch system. So important preliminary material. This is all about how to build and how the system is built. And as it says here, be very careful to follow the instructions. You ideally want to be copying and pasting stuff out of the book rather than typing them in. If you do type stuff in, be very, very careful. I've done it once. My first builds on 486s were manually. I knew very little about Linux at that point, then Linux or Linux from scratch. And in fact, Linux from scratch was my gateway into learning about Linux, learning about remote access and being able to copy and paste commands. So if you can do it like I'm doing with another system where you can just copy and paste from a graphical browser, it's a lot easier. It's a lot less error prone. But otherwise, if you are doing copying and pasting by eye and finger, type in the command and then reread it and double check that the command is accurate before you press enter. Toolchain technical notes, so some information here about the cross-compilation method that is used. It's not strictly a true cross-compilation method, but it's as near as damn it is effectively what's being done. And the reason is to segregate the host system from the final Linux from scratch system. Prior to using this method, I always felt a little bit uneasy about the final system that was produced. Occasionally you get some things happening that reflected the host system, even though you weren't running from the host system. But since they've introduced this, straight away I could see that it was a very much more robust system to separate the host from the Linux from scratch system. I've got a great deal of confidence in this, having seen it built the very first time and using every single version of Linux from scratch since that point, which was version 10. It's very, very robust, very durable, very good method of setting up the new system. I won't go through that because it's quite technical, but it may need some reading. I think in my cross Linux from scratch build, I go through a PowerPoint slide I created into a little bit more detail, or explain it in a slightly different way about how cross-compiling works. If you need some further information, or there's plenty of information on the internet about how cross-compilation works if you need some more information. But it's worth taking time to understand, to grasp and appreciate the technicalities involved in cross-compiling. You'll get a better understanding of what's going on when the commands are typed in or pasted in. So general compilation instructions: adhere to everything on this page to the letter, and you've got a much better chance of having a successful build. You'll see me go through this, religiously do this, but I'll just reiterate some of the more important points here. If at any chance, at any time you're not sure if LFS is set, just run that command and ensure it's pointing to the directory where the partition is. Also make sure the partition is mounted if you've just booted, if you've shut down for the night, if you've come back for another session. We've also already done the host system requirements. So again, if you shut down and restart again, it's worth rerunning that script to make sure that everything passes in that host system requirements. You don't want to break that setup if you do carry on, because it will break the build. Here's the build process. Basically, we want to be running out of the MNT sources. So let's do that now. Change into that directory. Like that, sources. Then with each package we extract it. You change into the directory that's just been extracted. You follow the instructions on the page to build that package. Then you change back to the sources directory and you delete the package after you've built everything. And that ensures that each time we build a package, we're using the fresh sources. Some packages get rebuilt at the same time. You don't want to be rebuilding from a source directory that you've previously built from, because it might not be in the same or the correct configuration to start a fresh build from. So it's safest just to extract every time and change into the directory and proceed building from there. So the first thing we're going to be doing is compiling 5 packages to build a cross toolchain. So the toolchain basically is the packages that you see on your screen. Effectively, the toolchain comprises this. Libstdc is part of GCC, but it needs to be compiled separately for the cross toolchain. So these 4 packages are the core of what's required to compile other packages. They're not the only thing that's required, but they are at the core. So we start straight away with binutils. So here we go with this process that you'll get to know very well. Binutils, extract the package. Now I always use these switches, these parameters, what arguments, call them what you like, for tar. X is extract, so that's mandatory. V to view the files being extracted. If you don't put that in, you can't see what's happening. It will just pause and then come back with a prompt when it's done. On a bigger package, on a slow disk, it may take some time and you'll be wondering what's going on. So I always use V to see what's going on. And the F specifies what file you want to extract. So again, that's mandatory really. So that's been extracted. We now need to change into the directory that's just been extracted, and then we can proceed with the instructions in the book. So the first thing we do is create a build directory for binutils and then change into that directory. And then we configure and build. Now normally I'd put in this configure command, press enter and let that complete, and then I'll go on to the next command. But as it says here, you could use the time command to find out how long all of binutils builds to get an idea of the SBUs. So let's do that. There's the first command. We insert the double and to say that once that command is completed successfully, carry on with the next command, which is make. Put another double ampersand in to say again, once that's completed, run the final command, and we terminate that meta command, if you like, with a semicolon and a closed curly bracket, and we press enter. So this is the configure command that's running at the moment, and this may well be the make command that's running now. Yeah, this is the make that's running. So this is the build actually running. And I guess it's probably take about a minute or two on this machine. Okay, so that's finished configuring, compiling and installing, and you can see it took just under 2 minutes in total. So that's our guide for an SBU. So the last thing I've got to do now is to tidy that up by deleting the package that was extracted and the place that we built that package as well, the location, and move on to GCC pass 1. So once again we go through the same procedure. We extract the package, change into the directory that's just been created, and then we proceed with the commands in the book. So the first one is to extract a package called mpfr and then rename that package, that directory that's been created, sorry. And again, do the same thing, extract a package called gmp and then rename the extracted directory from a version directory to an unversioned directory. And finally, the same thing again with a package called mpc, and we just rename it to an unversioned directory. On x86-64 systems, set the default directory name for 64-bit libraries to lib. So even if you run this on a 32-bit, the logic is in that code that it will just ignore that. So if you're not sure whether you're on 64-bit or 32-bit, just run it anyway and it will do the right thing. There's some information there about how that works. Now we're going to create a temporary build directory in which we build the GCC package as recommended by the documentation. We're going to configure the package for building. And when you copy and paste, just double check that everything has copied. Sometimes it's easy to miss the first few characters of the first line or even the last few characters of the last line. Just double check it. It can make all the difference between a successful build or not. So that's configured the build. What I'll do now is to run make. I'll just time this to see how long this particular bit takes because it's going to be the longest amount of time, and wait for that to finish building. Okay, so that's finished building. Now we're going to install it with make install. And now we've got to create a full version of the internal header using a command that is identical to what GCC build does in normal circumstances. So we go back to the root of the source directory and copy this command in, and that's done. Okay, so now we're going to extract the Linux API headers change into the directory that's just been created and start running the commands in the book. So let's clean the directory, create the headers with that command. Delete some files and then copy the rest to where they should be. And that's done. We can move on to Glibc. So that didn't complete properly, so what I normally do is tab twice to double check that I haven't left the output directory from previous build, which I couldn't have done because this is the first time we've built Glibc, but there is a patch file there, so that explains why the tab completion didn't complete the full file. So I'll just put the full stop in and press tab and then it does complete. So it's just a little double check to ensure that I'm not going to change into a directory or extract over an existing directory. So again for 64-bit, but there is something here for 32-bit here as well. Yeah, symbolic link for LSB compliance. And then additionally for x86-64, create a symbolic link required for proper operation of the dynamic library loader. So in both cases, 32-bit, 64-bit, this will do the right command. So as before, if you don't know, just put it in. If you don't know what architecture you've got. Now we actually run in that patch that we saw before to fix some things in Glibc, create a temporary build directory, change into it, and make some changes to the configuration. Then run the configuration for the build. And then we can compile the package. Right, so that's built. We can carry on. There's a warning here: if LFS is not properly set and despite the recommendations you're building as root, the next command will install the newly built Glibc to your host system, which will almost certainly render it unusable. So normally this is not too much of a worry when I'm building from a live image, but as I've got an installed operating system that is bootable, it's probably something that's worth checking. So the first thing I'll do is type in ID to check my actual login ID, and you can see it's LFS, so that's okay. And I'm just going to double check the LFS variable is set correctly, which it is, so I'm happy that I can carry on. If that had reported anything else, that would need to have been investigated, especially if this had reported root or if this was pointing somewhere else. So that's all okay. So let's paste that in there and install Glibc. And then fix a hard-coded path, and then do some checks to make sure everything's working as it should do. So the output of this command should match what's in the book, which just check this bit here, and yes it does, so that's okay. Now make sure that we're set up to use the correct start files. So again, the output of this command should match what's in blue in the book. Yep. And another command. Yep, that's fine. Yep, that's good. And it says a 32-bit system might look slightly differently, so that's something to bear in mind. Attempt to open MNT LFS user libc. Yep, that's fine. That's okay. So once everything's working correctly, clean up the test files. And it says building packages in the next chapter will serve as an additional check that the toolchain has been built properly. If some packages, especially binutils pass-tool, GCC pass-tool fails to build, it's an indication that something's gone wrong with the preceding binutils, GCC or Glibc installations. So let's tidy that up and install libstdc, which is part of the GCC package. So we extract the GCC package again. Change into that directory and start putting the commands in. So the first one is to build a temporary build directory. create a temporary build directory, change into it, configure for the libstandard C++ compilation. And build a package. Okay, we'll install that library we've just compiled and remove some libtool archive files, and that's complete.